So here we are back to finish that problem. So I had to play around with the numbers for a minute. The video is going to get too long. So playing around with the numbers, we had these two, 1.4 to 1. I went a little bit more detail, but I still got basically 1.4 to 1. So usually when you get a ratio like this, it'll look like this. It'll be 1.33, 1.67, sometimes 1.25, sometimes 1.5. So 1.5 to 1, 1.25 to 1, 1.67 to 1, 1.33 to 1. So in other words, they're usually halves, fourths, or some version of thirds. But in this case, we needed to multiply by, so it's 1.4. So what is 0.4 times what equals a whole number? Well, that'd be 5. Because if you multiply 1.4 times 5 and 1 times 5, so you'd have 1.4 times 5 is 7. So the answer to that would be 7. Put a different color here. So 1.4 times 5 is 7, key number. 1 times 5 is 5, and so that would be the empirical formula of this compound. So you'd have C7H5. Now it told us in this problem that the molecular weight of the compound was 178. And if you do 7 times 12 for carbon, 5 times 12 is 60, 72, 84. You'd have 84, and 5 makes 89. So the formula mass of this empirical formula is 89. And that doesn't match the 178 that he gave us in the problem. All right, so this I did not talk about in class. It's just an extension of the empirical formula. So what happens is 89 can go into 178 two times. So what that means is that this is the empirical formula, but the molecular formula is twice this, because 89 goes into that number twice. So the real formula is C14H10. So that would be your final answer on that one. So once again, looking at the process, it's just the same basic process for empirical formula. This was a weird one because it wasn't fourths, thirds, or halves. So it's a little more complicated. That's not against the rules, but it's just not as common. So you multiply by 5 and you get 7 and you get 5. So once you have 7 and 5, that's the empirical formula, just like we did in class. But since the molecular weight is 178 and the empirical formula weight is only 89, and then I got that again by 7 times 12 for carbon, 5 times 1 for hydrogen. Together is 89. 89 times 2 is 178. I'll show you real quick here, just in case you don't believe me. So 178 divided by 2, see, 89. So that's how you handle that kind of a problem. All right, now let's go on to 39. On 39, the problem tells us that we have element X and it forms a chloride XCl4. So you got XCl4. And you know that this compound is 75% chlorine. So if it's 75% chlorine, that means that you have 25% carbon. All right, so 75% chlorine. And we're going to have 25% X, whatever X is. All right, so I'm going to show you a couple different ways to think about doing this. The first one I'm going to do is the way I initially it just came to me that this should be the way you think about it. You know that the weight of 4 moles of chlorine is 75% of the total weight of the compound. So 0.75 of the total weight is equal to, so you're 0.75 times X, where X is the total weight. Because you know when you're taking a percentage of a number, that you would take this percentage of the number, you multiply percentage. Like if you're going to see there's a 20% discount on a couch or something, so you go 0.2 times the price of the couch. Okay, and that would equal then the mass of the chlorine. So the chlorine is 35, you should use 35.5 for chlorine. because it's 35.453, so at least use 35.5. So we do that, we multiply it by 4 because there's 4 of them in this compound. So that we know 75% of the mass of the compound is 142, where X would be the total of the compound. All right, so if you do that math, 142 divided by 0.75, you get 189.3. So the total mass of 1 mole of this compound would be 189.3. Let me run through that logic again. Assume we have a mole of this. 75% of the molar mass is chlorine. So that means 25 of the molar mass is X. Okay, so we know the total molar mass by using this process. We know that 4 moles of chlorine is 142, and that is 75% of the total mass. So the total mass is 189.73. So then if you subtract 142, you get 7.3. 8 minus 4 is 4, so you get 47.3. So that would be the mass of element X. So then you go back over here and you go to a periodic table, and the element that is closest to 47.3 on this periodic table that I have faith is going to come up in just a second, or 10 seconds. Come on, periodic table, load in here. I guess I'll just open it in Acrobat. My computer's a little bit slow. There it goes. Okay, this is my home computer. So you got 47.8, you got 44.9, you got 50.94. So the closest element to that is titanium. So we know that element X is titanium. There we go. So that'd be the answer to that particular question. All right, the next question that we had to do, I was going to show you a different way to do it too. Okay, so we know the way the textbook does it, and I'll run through their example. They said that you have 25 grams of X. Go back to Zoom. They said you have 25 grams of X for every 75 grams of chlorine. Okay, so that's what we said here. We know that the unit of the molar mass that we're trying to get is in grams per mole. So we'd like to know grams of X per mole of X. So see if we can make these dimensional analysis work out to get grams of X over moles of X. So we know that 1 mole of chlorine is 35.5 grams of chlorine. So that would cancel out grams of chlorine. Now I got grams of X per mole of chlorine. We know in the chemical formula that there are 4 moles of chlorine for every 1 mole of X. So you put moles of X here, and moles of chlorine here. That would allow moles of chlorine to cancel. And what we say, there were 4 of these for every 1 of those. So you have 4 of these for every 1 of those. And now if we do the math, we'll end up with 47.3. And the unit would be grams of X over moles of X. And that's your formula weight. So 2 different ways to do the same problem. You can use either one. All right, now let's go to the next question. So over here, what was the number on the next question? I'll go back and check. 39, 41, and 44. All right, so we'll go back. Maybe I better, I think you can see those better on this page. So what I said was 41 and 44, right? Yep. Yeah, 41, 44. Okay, so here we go, 41 and 44. Okay, so you got chlorophyll contains 2.72% magnesium. Okay, so let's write that down. 2.72% magnesium by mass. Okay. So we know that chlorophyll only contains one atom of magnesium. So this one is a simpler problem, I think, than the last one we did. Okay, so I wrote down what the problem told us: 2.72 grams of magnesium for every 100 grams of chlorophyll. So this includes everything else and the magnesium, and the of this 100 grams, 2.72 is magnesium. All right, so if chlorophyll only contains one atom of magnesium, so it told us we had one atom of magnesium in the chlorophyll, right? Everybody remember we talked about that a minute ago. There's one atom of magnesium in the chlorophyll. It tells us that in the problem. Assuming one atom per molecule. Okay, so magnesium's molar mass is 24.3. Go back over here. So there's magnesium's 24.3. So that means 24.3 is 2.72% of the total. Mathematically, you'd write 24.3 is equals in math language. 2.72% would be written 0.0272, you divide by 100, like you're doing a percentage of a number, of the total. So 24.3 divided by 0.0272 is 893.4. Or just say 893 because I went to 3 sig figs. And that would be the grams of 1 mole. And mole came because we said that 24.3 is equal to 0.0272 of x grams, but x grams would be the grams of 1 mole because this is 1 mole of magnesium. So grams per mole here. That's a dimensionless number, so grams per mole became your unit. All right. Just looked at a textbook, and it says a little different way to think about it. I'll let you trace that way out and make sure it makes sense to you if you like. Well, here, you know that 100 grams of chlorophyll, I just put Cl or O, contains 24.3 grams of magnesium. Okay, we know that, it doesn't contain that. It contains 2.72 grams of magnesium. That's that number there, like I just said up at the top here. So 100 grams of chlorophyll contains 2.72 grams of magnesium. All right, then you know that there are 24.3 grams of magnesium for every 1 mole of magnesium. But you also know that 1 mole of magnesium is 1 mole of chlorophyll. So the grams of chlorophyll per moles of chlorophyll are left. Grams of magnesium cancel, moles of magnesium cancel, so you have grams of chlorophyll for every mole of chlorophyll. All right, that was 41. I'm going to stop this video here just to keep it from getting too long.